Hey guys, so 9 to 8 wraps up the whole chapter. For this one, we're going to learn one final skill that's pretty difficult, all right, factoring by grouping, right? But besides that, they're just going to say factor completely, and then you're going to have to use all the different things that we've learned over the past few sections to factor whatever or solve an equation, okay? So this grouping thing is basically that undistributing thing, what we talked about with the first chapter or the first section of factoring is pulling out the greatest common factor, okay, more than one time. Okay, so what's going to happen is we're going to have more than 3 terms usually. So you're going to have 4, 5, 6, usually 4. And what you're going to do is you're going to group similar pairs of terms together. So pick out ones that look kind of similar that have a greatest common factor, put those together, and then factor the greatest common factor out of each of those. And then you'll have something in common in the whole entire polynomial, and you'll be able to factor a second time. Right? So it's like double grouping, double factoring, double undistributing. Like I said, I understand it. It seems difficult, but I'll show you what it looks like. Okay, so the first one here, these first two just kind of show you what you're going to end up with after you do your first grouping. Okay, so you see we have one term here and one term here. Okay, these are multiplied by each other. These are multiplied by each other. Okay, so there's just one term. Okay, this is the only plus sign that's being used here. All right, so we try to figure out what's common between these two terms, and we see that there's an x minus 3 in both terms. Okay, so what we're going to do is we're going to basically undistribute out, right, or figure out that the greatest common factor here is parentheses x minus 3. So we're going to pull the x minus 3 out of both of them. Okay, pull it out, undistribute it out. All right, and then we look and see what is left in each of these terms. So if we take an x minus 3 out of this term, we're just left with a 4x. If you take an x minus 3 out of this term, you're just left with a plus 5. So you'll be left with 4x plus 5 in here. Okay. The second one, very similar, same idea. All right, look at what's common here. Well, we see this y minus 5 and a 5 minus y. Okay, so we want to pull those both out, but the problem is our 5 minus y isn't quite the same as a y minus 5. Okay, so here's a little trick. Right, if these look very similar, but they're flipped, okay, they're flipped around. All right, you're going to take one of them and take out a negative. All right, so if you look over here to the right, right, I'm going to take 5 minus y, all right, and I'm going to take out a negative 1 out of here. All right, so take a negative 1 out of 5 and take a negative 1 out of y. And that's going to be equal to negative, there's my negative 1 I pulled out, and you've got negative 5 plus y. Now if you rearrange these two terms, right, this is the same as negative y minus 5. Okay, so this little trick is you can kind of just jump from here to here, okay, by pulling, if you have your two terms are flipped, you're still subtracting between, but your two terms are flipped, right, pull out a negative or basically change the sign, and then you can flip those two numbers. Okay, so that's what I'm going to do here. All right, so I'm going to take out a y minus 5. Okay, now remember for this one, in order to flip these two, I have to change this sign. Okay, to make it a y minus 5, I need to change my sign to a positive. All right, so what am I left with right here if I take out a y minus 5? Well, you're left with 2y squared. And what am I left with here if I take out a y minus 5? I'm left with plus 3. So that'll be the final answer. Okay, now the more difficult ones. Okay, so you're going to get a problem that looks just like this number 3 and number 4. Right, and this is where you have to start double grouping. Okay, so if we look at, a lot of times you're going to have your terms are already in the order that you want them to be in. Okay, so we're going to try it this way first, right, to look at them as two separate things just like that, and factor out the greatest common factor in this one and this group. All right, see where I have two groups? I'm going to factor out the greatest common factor in both of those. So the greatest common factor in this first group is an x squared. Pull out x squared, and we're left with x plus 2, right? When you take x squared out of x cubed, you're left with an x. When you take x squared out of 2x squared, you're just left with a 2. So it looks like that. All right, and the second one, my greatest common factor is going to be 8. Okay, so when I take an 8 out of 8x, I'm just going to be left with x. And when you take 8 out of 16, I'm be left with 2. Okay, so now you see that number 3 here looks very similar to what we had number 1 and 2. Okay, these are the same exact thing, right? They're not flipped like in number 2. They're the same like they were in number 1. Okay, so that means I can undistribute or factor those out. All right, so I'm taking an x plus 2 out of those two terms. And when you take an x plus 2 out of this term, you're just left with the x squared. And when you take an x plus 2 out of this term, you're just going to be left with plus 8. So it'll look just like that. All right, now number 4 will work all the way through. So once again, it looks like I could probably just group them the way they are. Okay, so I'm going to go ahead and do that. Grouping the first two, I'm going to take out an r, left with r plus 4. And the second one, I'm going to take out an s, and I'm left with r plus 4. Okay, now I see that I've got an r plus 4 in both of them, so we're good to go. Now I'm going to do my second undistributing, my second factoring, pulling the r plus 4 out, and I'm going to be left, right, when you take r plus 4 out of this term, you're going to be left with r. Take r plus 4 out of this term, you'll be left with plus s. Just like that. Okay, a couple more examples. So number 5 here, right, this is where we're starting to mix it up in the back side here, or I guess this is page 2, whatever you want to call it. Okay, so for this one, in number 5, right, I look at these first two and I'm going to probably group them together, but the problem with that is there's not any greatest common factor in x cubed and 10. Okay, so it's probably not going to help me very much. So I'm going to rearrange this, put the x squared over here, and put the minus 10 over here. Okay, so I'm going to go ahead and do that. I'll have x cubed, then plus x squared. Remember, you take the sign to the left of it with it. Okay, so the minus has to go with the 10. Oh, 2x squared. Then minus 5x, and minus 10. Okay, that's the same thing. Now I'm going to look at these two groups. Okay, now the biggest thing that is different about this one, all right, notice that it's at minus 5x. Okay, so I need the minus to be included in there. Okay, so remember this is like a plus, and I've got a negative 5x in there. All right, now I'm going to factor out whatever I can. So in this one, the first one on the left, the greatest common factor is x squared. Okay, so I'll be left with x plus 2. We've seen that before. And the second one, I'm going to factor out a negative 5. Okay, so if I take out a negative 5, all right, when you take negative 5 out of negative 5x, you're just left with x. When you take negative 5 out of negative 10, you're just left with plus 2. Okay, now we can factor out again because we see our x plus 2's are the same. So we have x plus 2, and you're going to be left with x squared in the first one and minus 5 in the second one. Okay, so now all rules are off, all right? We just try to factor in whatever ways we know we can. Okay, so for number 6, all right, this is just one of those trinomials. There's not 4 terms here. So we can go ahead and factor like we know how with an x and an x, all right, with two numbers that multiply to negative 3 and that add to negative 4. Okay, well, the only numbers I know that multiply to negative 3 are negative 3 and positive 1, or positive 1, or positive 3 and negative 1. Okay, so if I check this, I'm going to get x squared, right? I'm going to get a minus 3x, but a plus 1x, and then minus 3. Okay, so this is actually x squared minus 2x minus 3. Okay, so there's actually no way to do this that works. So for this problem, and you could get this, the answer is no solution or already factored. Okay, so this is incorrect. It doesn't work. It's just no solution. All right, number 7 here. Okay, we want to factor out anything that's common first. Okay, so we can look at what are the greatest common factors there. And the greatest common factor that I see is 3x. So I take a 3x out of 3x cubed, and be left with x squared. And be left with a 7 minus 7x in the second term. And in the third term, I'll be left with minus 18. Okay? Now, factor completely tells me that I don't want to just pull this out. I want to see if I can continue to factor anything. Okay, so I'm just going to leave that 3x out there, and I'm going to see if I can factor this trinomial with my x and x, right? Two things that multiply to negative 18 and add to negative 7. So I'm going to do minus 9 and plus 2. Okay, double check it, make sure it works. X times x is x squared. 2 times negative 9 is negative 18. We'll have a minus 9x plus 2x is negative 7. And we are good. That's the final answer. Now number 8, okay, once again, factor out the greatest common factor first. So I could take out an 8d from both of these. When I take 8d out of the 8d cubed, I'm left with d squared. And the second one, I'm just left with a 3. Okay, now, do we know how to factor d squared plus 3? No, we don't. All right, first of all, they're not both perfect squares. And second of all, this is a positive. It'd have to be a negative in order for us to do the difference of two squares. So that's completely factored. And lastly, okay, you'll have to solve these equations just like we've been doing in the past, okay, with any of the methods that we've learned so far. So we need to get everything to one side of the equation, set it equal to 0. So 2x cubed minus 18x squared. I'm going to add the 36x over, and that's equal to 0. Okay, now we pull out greatest common factor if we can. There is a greatest common factor. It's 2x. Take 2x out, we'll be left with x squared minus 9x plus 18. That equals 0. All right, try to continue to factor this trinomial. So leave my 2x out there. And looks like we can factor it. We need an x and an x. Okay, we need two negative numbers because it has to multiply to positive 18, so they both have to be positive, both negative. But it adds to negative 9, which tells us that we're going to need two negatives. So we'll try negative 6, negative 3. Double check this. We got x squared. We've got a plus 18. That's good. Then we got minus 3x, minus 6x, gives us minus 9x, and we're good. Now remember, once you get to this point, and we do have an equation, right? The difference to this, I don't say factor here, I say solve for x. So since I'm actually solving for x, getting an equation, right, either one of these three things has to be equal to 0. So either 2x equals 0, or x minus 6 equals 0, or x minus 3 equals 0. So the possible answers for x, there's three of them here, are x equals 0, x equals 6, or x equals 3. All three answers are necessary. And that sums up the chapter.